Here I'm going to go over that first review lab you did in T-Shoot. Here's the topology we had. I gave you the topology without the IP addressing, just the BGP autonomous systems, the OSPF areas, the AIGRP autonomous system, some physical layout, and then you had to pick the addresses based on the network I gave you. Here are kind of the ones that I chose. So we look at VLANs. I tried to make them relatively intuitive. So 10, 10, 10 is VLAN 10. .20 is 20, 30 is 30, and so on. All loopbacks, point-to-point interfaces were created with a 30-bit subnet mask. So between the link between R1 and R2 is 1010.1.0 subnet. On the other side, it's 1010.1.4 subnet, which me doing 1.2 here, .5, .6, and so on. So what might be helpful to you, so what I'm going to do is that my plan is to just follow the instructions as they are in kind of a generic form. There are certainly some optimizations we could do, especially if we had extra time to sit and work with BGP a little bit better, because we don't necessarily want all the BGP networks in our autonomous system, nor does the BGP internet want all of our networks as well. So there's certainly some optimizations we could do there, but we're going to take this just at face value the way it was and see if we can accomplish the tasks that are in the list. What will probably be really helpful to you is I won't always go, I have this in the slides, but I won't always go back to these. What I'm going to do is I'm going to refer to the actual lab itself after I've talked about this a little bit. So what might be easiest if you're going to watch this and try to follow along is to go through and actually pull out the review lab so you can see what step we're on. I will say this, I have done, so if I go through, I've done all the initial stuff. So I've done the IP addressing. Ooh, the only thing I did not statically configure, oh yes I did. So I didn't configure DHCP yet because that is in a further part down the lab. This is just kind of, hey, this is how things are going to happen. You're going to subnet, which I actually did. You're going to configure DHCP. You'll statically configure the IP address, and you'll assign addresses to the switches for management. So you just kind of know that you're going to need these addresses. I have done all of this. I've done all this in here except for the DHCP because that comes later, so let's get rid of that. I've done all the initial configurations, the host names, the IP addresses, the clock rates, and so on. If you struggled with that, I didn't see anyone that really did. I'll point out kind of the VLAN differences between the two DLS or distribution switches, but I didn't see anybody that really struggled with the addressing, passwords, things like that. If you did, send me an email. So we're going to start right away with the switches in the first switching portion. Well, I meant to underline that, not cross it out. Configure name VLANs. So DLS1, DLS2 should have VLANs 10, 20, 30, 40, 50, 70, and 8. That should be in there. And then ALS1 should have VLANs 10, 20, 30, 40, 50, and 8. You'll notice the difference is this 70, this peer network. I'll explain it a little more later, and I maybe should have had a bullet point on there. I was hoping people would figure it out, and then I kind of looked at it in hindsight and realized, no, that's probably too tough. So I'll explain that a little more later. But basically, OSPF, because of the way we set this up, OSPF is going to need a peering network, and we're going to use 70 for that. It's a network that ALS1 does not need, so we didn't put it on there. So we have configuring these VLANs, plus if we read down, we have to configure VLAN 101 on the switch. So let's configure all the VLANs at the same time. Whoa. And then let's go through and put the PC and the server in the correct VLAN. So I'm going to go ahead and I'm going to bring DLS1 over first, my console for that. So we have 10, 20, 30, so VLANs, whoop, 50. Oh, one thing I wanted to note first is the VLANs that we have. The interface VLANs that we have. So let's begin at VLAN 10. I can't remember. I don't think there's a space between it. No, there isn't. So one thing maybe we struggled with, I don't think we did at the end, but maybe we did early on, was these interface VLANs. So we had to have an interface for each VLAN, because we're also not only going to route them, but we're going to use HSRP on them. We're going to create HSRP on them. But because of how we had to do it, we have our VLANs acting like directly connected routers. So VLAN 10 on DLS1 connects to VLAN 20 on DLS2, or I'm sorry, wow, VLAN 10 on DLS1 connects to VLAN 10 interface on DLS2. Interface VLAN 20 on DLS1 connects to interface VLAN 20 on DLS2. So if I bring over DLS2 as well, So I bring DLS2 over. Let's do a show run begin VLAN 10 again over here so we can just kind of compare. As I said, I already did all the addressing, and this might be the only thing that we struggle a little bit with. Notice that VLAN 10 interface on DLS1, I gave it an IP address of 10, 10, 10, 1, and VLAN 10 on DLS2 is 10, 10, 10, 2, and so on. So they're behaving just like directly connected routers, as if I had physically connected 1, 2, 3, 4, 5, 6 interfaces. We didn't. We're going to connect them over a trunk, but they behave, and the way we have to configure them is basically the same way. So let's get this one to the side for now. Let's go back to this one. The other thing I want you to notice is the interface VLANs don't create VLANs. So if we do a show VLAN brief, we see that the only thing we have is the default VLAN. So let's go ahead and do our first step under the switching. 10, 20, 30, 40, 50, 70, 8, and 110. No, 101. Actually, do that, but we still have to then go in here and do VLAN 10, name. What's the name for VLAN 10? Whoa, spell name first. Name. Office. VLAN 20, name, guest. 30 is our management. Oh, name. $40 is where our servers are. VLAN 50 is voice. VLAN 70 is that pure VLAN I talked about. And I'll talk about some more. 8. 8. What is 8? That's our parking VLAN. And then 101 is going to be used for our native VLAN. So if we do VLAN 101, name native, that does not make it the native VLAN. It just lets us know intuitively when we're looking at our configurations that that is supposed to be our native VLAN. So one other thing here. One thing that's convenient to do in Notepad is you have this config. If you do a show run, it would show up like this. You just copy and paste it, or you could pre-type the config in. That way, now I have to go configure DLS1. I don't have to put everything in there. So I can just, I put this in Notepad. I can just copy it into DLS2. So let's pull our DLS2 window over. I'm working with this system saying, oh, it's not responding. There we go. And now we can just paste in, because DLS1, DLS2 have the same VLANs with the same name. So we can go ahead and paste that in, so we don't have to type that in. Now I'll go ahead and I'll bring up ALS1. And we do all of them except for the peer. So I'll re-highlight and do it. Whoops, that I did not want to do. There we go, re-highlight, copy. Pull up ALS1. Paste in the VLANs with the VLAN names. So now the VLAN part's done. So the first part about configuring and naming VLANs is done. Now we want to put PCB in VLAN 10. So we're already in ALS1, which is where PCB is located in Ethernet 18. So if I exit out, int FA0/18. Switch port mode access. I should probably type it out the first time, right? Switch port mode access. Switch port access. Give it access to VLAN 10. So that's just those two commands are what put PCB in VLAN 10. Let's go ahead and put the server in VLAN 40. So servers on DLS1. Let's bring up that console real quick. This Windows get a little busy, so I'm going to move this stuff over. But bring up our DLS1 console. Servers in VLAN 6 or is in interface 6. Switch port mode access. Remember, I can shorten it up as long as the iOS understands what it is we're trying to type. So SW space M space A is the same as typing in switch port mode access. Switch port access VLAN 40. So now we're done with the next two bullet points. It says put PCB and server in their VLANs. Configure all links between the switches to be trunks. So all the inner switch links Those are on each switch. Those are interfaces 1 through 4. All right, so let's configure our interswitch links to be 802.1q trunks. We'll disable DTP frames, and we'll configure native VLAN 101. So the interfaces that are between the switches are 1 to 4 on all switches, 1, 2, 3, 4, 1, 2, 3, 4, so on. Okay, so int range FA0/1 to 4, switch port, trunk, encapsulation .1q, switch port mode trunk, and then switch port, no negotiate. That disables the sending of DTP frames. So we covered that one. Now it's going to start yelling at us because now we're going to change our native VLAN. Switch port, trunk, native VLAN. And I probably should turn off logging to the console, but it helps me debug things if I make a mistake. So switch port, trunk, native VLAN 101. And let's go repeat that to DLS2. Int range FA0/1 to 4. Switch port, trunk, encapsulation .1q. Remember that's shorthand. Mode trunk, switch port mode trunk. Switch port, no negotiate. Switch port, trunk, native VLAN. Switch port, trunk, native VLAN 101. Now they should hopefully start getting a little happier. And last but not least, 1 to 4 on ALS1. So let's bring him over. Int range FA0/1 to 4. Switch port mode. Here you don't have to do encapsulation because the only option on these 2960 switches is .1q. Switch port mode trunk. Switch port, no negotiate. Switch port, trunk, native VLAN 101. Hopefully we're good now. Let's do a show int trunk. And right now we have 4 interfaces trunking. Encapsulations .1q, native VLANs 101. And it's actually unblocking now, so our consistency's been restored. Next 2 bullet points say, next 3 bullet points we'll take together. It says configure all links between DLS1 and DLS2 to ether channel manually, which means on, which means I'm not using a protocol to create the ether channel. Configure all links between DLS1 and ALS1 to ether channel dynamically using PAGP, which means the protocol I'm using is PAGP to form the ether channel. And then configure all the links between DLS2 and ALS1 to ether channel dynamically using LACP. So let's start with DLS1. Okay, so let's just exit back one even though we don't have to. It says DLS1 and DLS2 ether channel manually. That's going to be my port channel 1, and those are the 3 and 4 interfaces. So int range FA0/3 to 4. Might be a good idea to shut them down first, especially when we do lab. I'm going to try to go with it and hope they stay up or go down and then come up. Channel -group 1 mode on. And then the other one that's on DLS1 is between DLS1 and ALS1, and that's supposed to use PAGP, and I'm going to use port channel 2 for that one. So that's interfaces int range FA0/1 to 2. Channel group 2 mode desirable. Desirable is the keyword that tells me I'm going to use PAGP. So DLS1 should be done. Let's go to DLS2. So I'll bring that console window over. I know how many people are going to say, I can't watch those consoles. Int range FA0/3 to 4 because those are the interfaces between DLS1 and DLS2. So we're on DLS2 and we're DLS1 and DLS2 ether channel manually. So channel group 1 mode on. And then between DLS2 and ALS1 we're using LACP. So int range FA0/1 to 2. Channel group, and that's going to be the third port channel. Channel group 3, mode active. Active is the keyword telling me I'm using LACP. And we'll bring over the console for ALS1 and go ahead and configure the ether channels there. Did I remember? I think I did. Okay, we did. Int range FA0/1 to 2 is connected to DLS1, which means that's port channel 2 and it's using PAGP. And int range FA0/3 to 4. There you go. Int range FA0/3 to 4. So that's going to DLS2, correct? And so then that is LACP. Mode and active. All right, so hopefully we've successfully done it. Let's give everything a chance to kind of reset. But we did all the VLANs. We put our PCs that we were supposed to in the VLANs. We configured all the links to trunking. We disabled DTP. We configured the native VLAN to 101. Then just now, we configured links between DLS1 and DLS2 to ether channel manually, between DLS1 and ALS1 to use PAGP, and between DLS2 and ALS1 to use LACP. Now let's do a show ether channel summary to hopefully see them up. Okay, in ALS1, both those port channels are up. We'll bring over DLS2 and do a show ether channel summary. Oh, yay, and they're up. And you'll notice there's no protocol here because remember, port channel 1, we're not using a protocol. It's just on. We're using LACP, so that's good. If both those are up, this one should be up unless we have some weird something happening. Show ether channel summary. All right, so all our ether channels are up. We've now successfully done the next 3 bullet points for the switch. And then we've got put all unused switch ports in the parking VLAN, configure all unused ports to access mode, and shut down all unused ports. I'm just going to do this on one of the switches. Might as well just do it on DLS1 since we're there. Basically repeat it for all the switches. There were 2 you in a group, so I'm just kind of showing you the configuration, not necessarily do it everywhere. But you would go ahead and do that if you were completing your lab. You know, each person would take a switch or 2. So all unused switch. So anything we want to do, we basically want anything we're not using, we want to secure. Shut it down, put it in a different VLAN in case someone gets access to it. And certainly make sure it's not trunking. If I look back at my topology, I'm using 1, 2, 3, 4, and 6, and 5. So I'm using 1 through 6. So 7, say 7 through 24 are unused ports in this instance. Range FA0/7 to 24. Oh, what does it say? Parking VLAN access mode and shut down. So switch port mode access, switch port access, VLAN 8 is our parking VLAN, and we just shut them down. And we just let it tell us it's all administratively down. And just repeat that config for all the unused interfaces for the other 2 switches, which I won't do here, but now you've seen it. So we've done the next 3. We're almost done with the switching section, sort of, at least bullet point wise. Now we've got to configure MST, right? So it says configure MST. VLANs 10, 30, and 40 are in instance 1, and 20, 50, and 70 are in instance 2. So I'm going to make my domain for my MST instance just called CNIT444. So spanning tree, MST configuration. Name CNIT444, revision number will be 1. So instance 1 has VLANs 10, 30, nope, and 40 in it. Got to spell VLAN correctly. Got to spell instance correctly as well. Instance. There we go. And then instance 2 has VLANs 20, 50, and 70 in it. Now, last but not least, after we've done the configuration, let's exit back out, and you actually have to change the spanning tree mode. So configuring MST, actually doing the configuration like we did here, doesn't change the mode. So if I do a show run, let's just do a show run. It's going to be right in the beginning. Well, just do a show. It's been a long day. Do show run. The spanning tree stuff will be right in the beginning. So it's really, okay, I lied. Forgot about the, there we go. You see the spanning tree mode still PVST, so we've got to actually change the spanning tree mode now. Spanning tree mode MST. Go ahead and repeat that over on DLS2 and ALS1. And what else you do is you remember to put those things on notepads, so I'll just copy and paste it. I actually have this configuration. You saw it just like I did with the VLANs. Just makes things a lot faster, especially if you have to repeat it, and if you have to repeat it by yourself. All right, so go into ALS1, config T, and then paste in the MST configuration I just gave you, because it has to match everywhere. If you want the switches to communicate via MST and have those same instances, they've got to have the same exact configuration there. And then go ahead and do, oh, first, forgot, I did have it in my, I didn't realize. I did have the spanning tree mode in there. That's what I was looking at. T. Paste our spanning tree in. And now you notice our VLANs are coming up. So now we've configured the MST, configured DLS1 to be the root bridge for VLANs 10, 30, and 40, and DLS2 to be the root bridge for 20 and 50. And because we're using MST in instances, it should really say 20, 50, and 70, because that would be instance 1 and then instance 2 in that list. So we're in DLS2 now. Let's just go ahead and configure the DLS2 part since we're in there. So spanning tree MST, and then the instance number. So it's instance 2 that DLS2 will be the root for. Root, we'll just run the primary macro, which will just change the priority. If you do a shell run, you'll actually just see the priority number as being different, but we can do spanning dash tree MST, the instance number, which is 2, root primary, and then we'll do spanning tree MST instance 1, root secondary, and then just swap that over in DLS1. Spanning tree MST 1, root primary, and then spanning tree MST instance 2, root secondary. Okay, so both the root bridges are done. Now it says configure HSRP on DLS1 and DLS2. DLS1 will be active for VLANs 10, 30, and 40, and DLS2 will be active for VLANs 20, 50, and 70. All right, so again, we'll do DLS1 first. I'm going to configure one VLAN group, or one HSRP group per VLAN. And we'll just name them. The group number will be the VLAN number. So let's do, okay, I'm going to do all the active VLANs first. That's just easier for me to kind of remember. So 10, 30, and 40 are active. I'm sorry. Read that again. Yes, 10, 30, and 40 are active on DLS1. So int VLAN 10, standby 10 IP, and the IP I'm going to give is 10.10.10.3. I've already used 1 and 2, so I'll use .3 as my virtual IP. And then I want this to have a greater priority than 100. Standby 10, priority 110. Can't spell standby. Did I spell priority right? Standby 10, I did. Standby 10, priority 110, which will make VLAN 10 active for, or interface VLAN 10 active in HSRP for DLS1. And we'll go ahead and we'll configure preempting on all of them. So standby 10, preempt. And that's all we got to do there. Next one, int VLAN 30. Trying to remember which ones are supposed to be active. Standby 30 IP 10.10.30.3. Standby 30 priority is 110. Higher priority is preferred in HSRP. Standby 30 preempt. And then last but not least 40. No, well, not last active. Okay, so int VLAN 40. Standby IP 10.10.40.3. Standby. Ooh, I made a mistake up here. Look at this. I forgot the group number. I guess it's a useful thing in case I do that to you later, right? If you forget the group number, it actually defaults to a group number of 0, which takes it outside of this group. So basically, there's a group 0 without an interface that it belongs to. So let's actually get rid of this. No. Standby IP 10.10.40.3. Ooh. See, it even says VLAN 40 group 0. Now it's mad at me. There we go. Now let's fix it. Standby 40 IP 10.10.40.3. There we go. Standby 40 priority 110 or 110. And then standby 40 preempt. Okay, so 10, 30, and 40 are done. Now we've got to do 20, 50, and 70. Int VLAN 20. Standby IP. Oh, standby 20 IP. 10.10.20.3. That's all we really got to do here, but we'll go ahead and do the standby preempt anyway. Int VLAN 50, standby 50 IP 10.10.50.3, and then int VLAN 70, standby 70 IP 10.10.70.3. Okay, I think I did them all now. I'm talking and doing it. It's hard to remember. Configure HSRP. So we did 10, 30, 40. Let's try this. Let's do a do show run begin. I should have waited. Let's get rid of that. Just double check. So we started, well, first time we saw standby, which would have been in VLAN 10. Priorities up. Oh, look at, see, good thing we double checked. I messed up VLAN 20. Let's see if I messed up any other ones. 30. 40 is supposed to be active. 50 is not active. Should be standby. Sorry. Okay, so I think it's just 20. So we have VLAN 20. No. Paste. And then configure it correctly. So HSRP is done on DLS 1. We'll go over to DLS 2 and configure HSRP. I did not put some of this in Notepad. I could have. You could have put at least the standby IP. Those all would have been the same. But I didn't. So here we go. My actives for DLS2 are 20, 50, and 70. So let's go ahead and do those first. In VLAN 20, standby 20 IP 10.10.20.3. Remember, the standby IPs can match. Nowhere else can you have directly connected interfaces, or their regular IPs can't match, right? They have to be in the same subnet, but they can't match. But your virtual IP needs to match. In fact, that's the IP we'll use for things like our default gateway. So standby 20 IP 10.10.20.3, standby 20 priority is 110 because this is the active one. Standby 20 preempt. So 20's done. Int VLAN 50. Let's just hit the up arrow. Oh, I can't. So we'll hit the up arrow and change the 20 to a 50. Oh, dang it. I put my number in before I hit enter. That's what I get for not typing it out. So standby 50 IP 10.10.50.3. Standby 50 priority is 110. And standby 50 preempt. 50's done. Int VLAN 70. Standby HSRP group number, which is 70. IP 10.10.70.3. Standby 70 priority 110. Standby 70 preempt. So now let's go back and do the other VLANs that DLS2 is going to be in standby for, which will be 10, 30, and 40. Standby 10, IP 10.10.10.3. Standby int VLAN 30. Standby 30 IP 10.10.30.3. And 40. Interface VLAN 40. Standby 40 IP 10.10.40.3. All right, I think I did it all. Let's check again. Let's check to just make sure we've got it right. Pipe to begin. First time I see standby. Whoops. We'll get 10, 20. Oh, I did it again. It's that preempt command that keeps getting me. Let's double check. So 10, 20. I did it twice. In VLAN 30 and in VLAN 40. Too bad you guys on the other side can't yell at me while I'm doing it. It's better when I do it in class. So 30 and 40, huh? Int VLAN 30. Standby 30 preempt. Int VLAN 40. Standby 40 preempt. Let's double check again. And 10? No. Did I just do 30 wrong again? Oh, I didn't take it off. Okay. So I just copy and paste to get rid of the bad stuff. Double check it. Triple check this time. All right, looks good. So HSRP is done. Donezo. What do we got next? Oh, configure the routing now. So we need to configure the routing. Configure routing on DLS 1 and 2 according to the diagram. DLS 1 and 2 are in area border routers with networks in both area 0 and area 1. Loopback interfaces, so I'm looking at the next 3. Loopback interfaces and interface 5 on DLS1 and DLS2 are in area 0. The rest are in area 1. See, and I wish I would have put another one in here that says VLAN 70, or our peering VLAN will be in 0, because we got to put it in 0. All right. So I said I would explain this peer VLAN thing a little better, or why I'm peering with, or why I created a VLAN to peer called peer. One of the rules of OSPF is area 0 has to be contiguous. And the way I have this laid out, or way this is laid out, is that this here is all area 1. And what that does, if I don't create an area 0 link between DLS1 and DLS2, it creates 2 separate area 0s, one here and one here. And that doesn't work for OSPF. For OSPF, it has to be one contiguous area 0, not broken up. And the funny thing about this is because both DLS1 and DLS2 see themselves in area 1, and they see themselves as connected to area 0, they have no idea that area 0 here is discontiguous. They see themselves as connected to area 0, which is proper design, so they're not going to throw any errors at you. So what we need to do is we're going to use VLAN 70 to create the link between DLS1 and DLS2. So now what happens is I go down into 70 that's in DLS1, and that creates my one contiguous area 0. I hope that sort of makes sense. Or in a sense, it connects. Now, it connects down in DLS1, but to see it visually, maybe it connects it. So now I have one. Let's see if we can use our, let's not do that. So if I use 70 across this link here to connect our two discontiguous area 0s, then I end up with one contiguous area 0 across 70. So that's what that 70 was there for. And in my first thought process, like, oh, I hope people see that. I hope they draw it out and see that, until we peer with something. And I chose 70, and that's why I named it peer. We have two discontiguous, we have 2 area 0s, and we can't. They need to be one whole area 0. But in hindsight, I do wish I would have put a bullet point there, because I see how that could have been really difficult. But that's why we need area 70, or VLAN 70 interfaces, and we're going to route it in area 0 to connect these 2 here. Let's get rid of this in case I need this ink, or I need that later. So let's go back. Let's go see where we're at. Since we're back at this PowerPoint right now, let's go back and see what we've done so far. We've done all of this, all the VLANs. I think we've done everything on this page, right? We've configured the ether channels. We've configured all the unused ports correctly. We've configured MST. We've configured the root and secondary root bridges. We've configured HSRP. So now we're to the part where we want to configure the routing. We'll do that all at once, and then we'll configure the port security. When we're done there, we can go on to the routers themselves. So, brought the DLS1 window over first to configure routing. Config T, router OSPF. I actually thought, and I think it was because I was going to build on this, that I had pulled out IPv6. So this one wasn't, this part at least wasn't too bad if I would have maybe given you a bullet point or a little more of a hint on that peering VLAN. So router OSPF 1 network. We got a lot of networks, right? Because we got a lot of 4 host networks, or we've got 2 hosts, 2 usable addresses, so 4 address networks. So we've got network 10.10.1.8, and not all of them on the device are in the same area, so it's kind of interesting. And then a wildcard of 003. Okay, the 1.8 network, where is that again? The 1.8 network is actually the link between DLS1 and R1, and that should be in area 0. That's that. So area 0. Wow, I missed all that. I keep talking and I missed this whole error back here. Oh goodness, IP routing. Now router OSPF 1 network 10.10.1.8 with a wildcard of 0003, and it's in area 0. The other network we have in area 0 is our loopback. So our loopback address, or our loopback network, is 10.10.1.28 with a 003 wildcard. And then now we've got all the rest of our, well, let's do our other, no, let's just leave it. Let's do all our VLANs. So we'll do all our VLAN networks. 10, 10, 10, 0. If it has a 255, 255, 2550 subnet mask, that means it is a 0.0.0.255 wildcard, area 1. And so we'll go the up arrow, and we'll change that to a 20 for our VLAN 20 routing. And then 30. Uh-oh, what do I do with though? 30 is in area 1, and then 40 is a little different because if you remember I had you subnet 40, it was just part of the instructions to see if people could subnet. So I actually did, I think you could have 42 hosts, and the closest you could get, or 43 hosts, maybe the closest you could get was 63. So 10, 10, 40, and then the wild card in this one is going to be 63. And we still have 50 and 70 to do. 50 and 70 were both 24-bit subnet masks, so all right, I'm going to get rid of this. I just wanted to get that message to stop coming up. It had nothing to do with what we needed to configure, what we needed to work on, so I paused it for a second while I did that. Let's go back. So now we've got to do the 50 network. Wildcard of 0.0.0.255. 50 is also in area 1 because it's one of the VLANs. And then last but not least, we got to make sure that we do our peering VLAN, and it has to be in area 0. So 10.10.70.0. 255, and that'll be in area 0. That will, if I do that on both sides, that will make our area 0 contiguous. I'll go ahead and do it on DLS2 now. What was that close? Router OSPF 1. Oh, I can hear you already, John. OSFP. OSPF. Again. All right, so our area zeros on this side on DLS1 are the link, I'm sorry, on DLS2, are the link between DLS2 and R3, I think, oh, and a loopback. There's another loopback on DLS2 as well. So the network 10.10.1.12 with a 0003 mask, area 0, and the other network 10.10.1, that loopback is 36, looks like. 10.10.1.36. And since now we've done the pure and I've kind of beaten that explanation up, let's go ahead and do that one. So our 70, 10.10, 70.0. And then the rest are all in area 1. Those are all our VLANs. So let's go ahead and configure our VLANs. Network 10.10.10.0. And these are all 24-bit subnet masks, which makes them 0.0.0.255. Come on, 0.255 area 1. And you can see that across 70, we formed neighbor relationships, or we formed adjacencies. We have across 10 now. Let's do 20, an up arrow, if I'm quick, 30, and then 40 is the one that's different. I was just kind of waiting for the VLAN 30 adjacency to come up. And that's a 63 wildcard mask in area 1. Let's hit the up arrow twice to get 30, and then we'll do that for 50, right? So should have waited. So for the 50 network, I think that's everything. Hope so. Oh, we did 8. No, we did 12, 36, and then 10, 20, 30, 40, 50, and 70. So I think that's it. Show IP route. We've got some OSPF stuff happening, so that's good. All right. So let's OSPF on the switches. And then it's port security. I'll go back and double check my routing, but I think I'm pretty sure that's it. I'm pretty sure we got everything on that one. So it says configure port security on ALS1 to dynamically learn 2 addresses on port 18, and then on DLS1 to only allow the server to connect. It says to connection, but it should say to connect. Interface 06. So port security to allow 2 addresses to be dynamically learned. Int on 18, right? On port 18. So first, switch port security. Enable port security. Switch port security. Come on. Maximum, so our number of addresses. Our max will be 2. And then switch port security. MAC address. I'm going to tell it MAC address sticky. So I can type 2 in if I want to do it statically. Here what's going to happen is the switch will dynamically learn 2 MAC addresses that come in. It'll do that without this command here. I mean, it'll do that without this keyword, but with this keyword, it actually puts the MAC addresses that it learns in the running config. So you could do a copy run start, and those addresses would always be saved there, so you don't have to configure them. So if I do show run include MAC-address, I get all the commands now that include MAC address. Here's the one I entered, and here's the one it automatically learned and put in the running config. So I do have a PC connected. This is the MAC address of that PC. If I had another one connected, it would learn another one, and then I would have this command again, but with a different MAC address over here. So that's done, and the next is configure port security in DLS1 to only allow the server to connect to the interface. So if we go to DLS1, which I think is just back here, yeah. Int FA0/6. Now there's a couple things you could do. You could do switch port security MAC address and actually type in the MAC address of the server. This time all I'm going to do is switch port security sticky because I know that's all I have connected to it. It will learn the MAC address of the server and it will stay in my running config. So switch port security, I have to enable it. Actually, just like MST, the other commands don't. The configuration commands don't necessarily enable it. Kind of like MST. We could configure MST, but it didn't necessarily enable spanning tree mode MST. And switch port. MAC address sticky. Okay, so the only 2 commands I did a lot of tab completing, so that's why you have all this other stuff. The only commands, I go to the interface, switch port security, switch port security MAC address sticky. Now it will only learn 1 because the default number of addresses that we learn is 1 unless I change it. The default will be 1, and you change it by using the maximum command that we did over in ALS1. Okay, I'm going to stop this video because this one's already super long. I'll come back with a part 2 that will do the routers, but the switching stuff is done. We've done everything in the switching parts at this point.